Well, you may have a little trouble with this because of the time squared part, right? That time squared, John, is kind of difficult. So let's take a look at what's going to happen here if we were to look at this more analytical way. So if we were to convert 25 meters per second squared to feet per minute squared, okay, let's take a look what this second squared looks like, okay? So here, if I were to rewrite this, second squared is same as seconds times seconds. So 25 meters per second times second is what we have. So if we were to convert this meters into feet, well, let's convert it into inches first because that's what we know. So in 1 meter, there are 39.37 inches in 1 meter. Now we can convert that into feet by saying 1 foot is equal to 12 inches. Okay? So when we work this thing out, the meters will cancel out, inches will cancel out, and giving us feet at the top. However, when we want to convert this second squared into minute squared, we can say there are 60 seconds in 1 minute. But that only takes care of one of the seconds. So we need to do it again, saying 60 seconds is equal to 1 minute. So now we have minutes squared at the bottom, getting rid of the second, okay? And if you work that out, you're going to get 295,275 feet per minute squared as your answer. Okay? Now let's take a look at number 6. Here again we have hours squared. So hours squared is same as hours times hours. Okay? So knowing that fact, we can say 10 miles per hour squared, right, is what's given to us, or 10 miles per hours times hours, right? So if we convert the miles into meters first, so in 1 mile, there are 1,610 meters. And then in 1 meter, there are 100 centimeters. So here we have miles canceling out, meters canceling out, giving us centimeters. Then we have to change our hours squares into seconds squared. So I'm going to skip in between minutes to second part and just go directly from hours to seconds. Okay, so 1 hour is equal to 3,600 seconds. Okay, that would cancel out one of the hours, so we have to do it again. So 1 hour per 3,600 seconds. So now we get the second hour canceling out and leaving us with the correct units. Therefore, if we work this out in our calculators, we will get 0.124, right? 2283951 centimeters per second squared. All right. All right. So the distance from the Earth to the Sun is known as 1 AU, astronomical unit. How many inches are there in 1 AU? Right? So we know 1 AU is equal to, I think I gave you this number previously from the other problem, so 93.835 million miles is how far 1 AU is. Therefore, if you were to convert that, so 93.835 times 10 to the 6th miles and let's convert that into meters first. So in 1 mile there are 1,610 meters, and that would get rid of the miles, and then in 1 meter there are 39.37 inches in 1 meter. So that was pretty easy, right? And that is equal to I get something like 5.94779716 times 10 to the 12th inches. All right. Are there any questions so far? Everybody okay? Okay, good. So let's take a look at number 8. Let's fly to the moon, right? Fly me to the moon. Oh, it says here, if we were to fly from the Earth to the moon, how long will it take? Now, when they say how long, it sounds like a distance here. But what they really mean is, like, how many... I'm going to say how many days, because that just sounds more, human scale. So instead of how long, I'm just want to say how many days would it take? Okay. Assume the speed of the plane happens to be 600 miles per hour. So that's good to know, right? So we know the speed is equal to 600 miles per hour. So let's write down everything that we know. Then we also know the distance from Earth to the moon is 384.4 million meters. So the distance, let's write down the distance here. The distance from Earth to moon is equal to 384.4 million meters. It looks like we have mixed units here. We have miles per hour and then we have meters. Doesn't jive that well, right? So we're going to have to change one of these Johns into something that can jive with the other one, right? So it's probably easier to convert this meters distance into perhaps miles, right? So we already know how to do that. So if we were to convert this distance into miles, all we have to do is just multiply this distance by its conversion factor, of 1 mile is equal to 1610 meters, then notice how the meters will cancel out, giving us our distance in miles. And that comes out to, I guess, 238,757.76 miles. So now that we know this, we can simply use that speed is equal to distance divided by time. And since we're looking for time, we just have to multiply both sides by time and divide both sides by speed to isolate time. Then time is equal to then, right, distance divided by speed. Therefore, if we plug in the distance in the same unit as miles, as 238,757.76 miles, divide that by the speed, which is 600 miles per hour. Notice how the miles would cancel out and bringing the hours at the top to get the correct time. So the time, when we calculate this, comes out to 397.9, I'm going to just round it for now, for 3 hours. So this is how many hours it's going to take us to fly to the moon. But I want it in days, so we could see it more of a human scale, right? How many days would that be? So if we were to convert that into days, so 397.93 hours, multiply that by 1 day is equal to 24 hours, right? So that comes out to approximately 16.58 days to fly out to the moon on a commercial jet airliner. All right. So roughly 2.5 weeks to fly out there, right? But you know, you have to go through all that, you know, checkpoints and landing and, you know, departure procedure, and then you have to go through the customs, and so it's going to take about 2 weeks, a little more than 2 weeks, like 3 weeks maybe even, right? You have to go through the immigrations, and it's just too much of an hassle. All right, let's take a look at the last problem for today. Your car is estimated to get 30 miles per gallon. If you drive at 60 miles per hour for 2 hours, how many gallons of gas did you use? It sounds like a pretty simple problem, but when you try to work it out, you're like, How do I even work this thing out? Well, let's understand what that 30 miles per gallon rate is, right? 30 miles per gallon means every 30 miles you drive, you will be spending 1 gallon of fuel, right? That makes sense. So if you drive for 60 miles, how many gallons of fuel would you use? Show me the fingers. How many? If you drive 60 miles, how many gallons would you use? There you go. Yummy. Yeah, peace. But two gallons is correct, right? So now that we have that in our idea, maybe we should find out how many miles we drive first. So let's find the distance first, and then we can figure out how many gallons we're going to use, right? So since we know the fuel rate is 30 miles per gallon, so every 30 miles we drive, we're going to use 1 gallon. So find the distance first. Okay? So if we were to drive, right? So since speed is equal to distance divided by time, if we look for the distance, distance is really nothing more than speed times time. The speed is 60 miles per hour. And since time is given to us only 2 hours, all the units work out pretty nicely. So we actually drive the distance of 120 miles. So since we know exactly how many miles we drove, so if we drive 120 miles and we spend 30 miles per gallon, how many gallons do we spend? Come on, you can show it to me with one hand. Show me your fingers. How many gallons do we spend? Come on. There you go. I like this face a lot better than your meme that you got. That picture looks really creepy, dude. Is that like a swimmer's goggles? I can't hear you because you're muted. Dude, that picture looks really creepy. Anyway, all right, Hayden said 4 gallons, and 4 gallons is correct. All right, thanks for bearing with me with all the glitches and lags. Okay, next time I'll stop my Minecraft and I'll stop my Discord, and hopefully that's going to help the bandwidth. Just kidding, I don't play that stuff. Anyway, I'm going to end my lesson here, and hopefully I'll get this lagging thing issue taken care of. I just ordered a USB 3.0 Ethernet adapter, so hopefully I'll be hardwired, and then hopefully that's going to reduce some lagging. So thanks for bearing with me. I'll let you guys go a little early towards the parking lot to beat the traffic, and since you guys are seniors, you could do that, right? So I'll see you Friday. All right. Have a wonderful day. Don't forget, Friday, there's no homeroom. So make sure you go to your first period class directly starting Friday. All right. Not that it matters for us, but so you don't want to be late for your first period. So have a wonderful day, everyone. All right. Thanks for sticking through. All right. Take care. Bye bye.
Thank you. Thank you. Yes. Thank you.
All right.